Hey, Superstar students, this is Dr. Conklin. We are going to do a short review today of a bunch of the things that we've learned this week to get us ready for the weekend. So I wanted to first review how to simplify radicals. So remember, a radical is when we have this neat symbol here. Could be a square root, it could actually be a cube root. And I want to go through the steps that we talked about in class. So let's start with an example, square root of 50. Our first step is we're going to punch this into our calculator. Oh, I thought I had my calculator up. There it is. Okay, we're going to do, oops, let me get out of this. Clear, oh dear. Second quit. Sorry guys, second quit always works. And we're just going to look to see, is the square root of 50 a nice number? So if I look at this, square root of 50, definitely not a nice number. So this is not going to be a perfect square. So I'm going to go and I'm going to start by listing the factors. So I know 1 in 50 is a factor, but we also learned a sneaky way that we can do this in our calculator. So I'm going to go to y equals, I have something in there, so I just got to clear it out. I'm going to do 50 divided by x. Once I do that, I can hit second table, and it's going to give me all the factors of 50. So 1 in 50, 2 in 25. Let me write these down. Now, just be careful. A number like this, 3 and 16.6 repeating, is not a factor because they're not, the 16.6 repeating is not a whole number. Same thing with the 4 and 12.5, not factors. But we do have 5 and 10, which looks good. Anything else? And remember, guys, we have 5 and 10 and 10 and 5. That's the same thing. Remember our friend, which we'll talk about in a little bit, commutative property, changing the order. So if I look at these, which one of these is a perfect square? Well, the only one is this 25. So, and again, I'm sorry, 1 is also a perfect square, but it's not the biggest perfect square. So I'm going to split this up, square root of 25 times square root of 2. And then this I can put in my calculator. So the square root of 25 is 5 square root of 2. Okay, so I'm going to have you try to first write the factors of 90. So I want you to try to do this on your calculator first. Okay, and then I'll walk through. We have 1 in 90, and then I'm just going to go to my calculator, go to y equals, close, y equals, I'm going to clear this out. 90 divided by x, second table, and then I'm going to go down and look to see if we have anything. So we have 1 in 90, 2 in 45, 3 in 30, 5 in 18. Oh my gosh, there's a lot. Okay, let me get started writing. 1 in 30, 2 45, 3 and 30. Was there a 4? I don't think there was a factor of 4. Nope. 5 and 18. Oh my gosh. 6 and 15. I don't think there was anything for 7 or 8. 7, 8, 9, and 10. And then you guys see 9 and 10 start to repeat. So if we look through these factors, which one of these are the largest perfect square? So 1 is a perfect square, but the only other one that's a perfect square is 9. So we're going to use this 9 and 10. I'm going to split this up. The square root of 9 times the square root of 10. So the square root of 10 is, or the square root of 9 is 3 square root of 10. Perfect. Okay, now, in order just to check our work, I'm just going to show you one quick trick. This square root of 90 should be the same as 3 square root of 10. So one way to do this, to check it, second quit, is I'm going to type in second square root of 90, right? That's 9.486, da-da-da-da. And then our answer was 3 square root of 10. And those are the same. So that's one really easy way to check your radical work. Okay, we just have a few more to check in. I wanted to review distributive property too, because we're going to be covering this a lot this year. So when it says combine like terms, but usually we'll say to simplify, all we're going to do is distribute this 5y and distribute the 5 to negative 4. So 5 times y is 5y. 5 times, be careful here, negative 4. So a positive times a negative is a negative 20. And then since these are not like terms, we can't do anything else. We got to just leave it. So that's our answer. Yay. Math sunshine. Okay. And then same thing for this. So why don't you try this one on your own, guys, and you can check it with our Edpuzzle. But the answer to this one, we're going to distribute the 7 to both places, our little rainbows. 7 times W is 7W. 7 times negative 3 is negative 21. So I hope you got that one right too. Superstars, superstars, superstars. Okay, and then last but not least, we're going to just do a little review of properties. So I just want to remind you, we have a couple important properties. Commutative property. And the trick with commutative property is we are going to remember to change the order. So if you see the little C and the O, change order. We have associative property. And the trick with this is we remember we're going to move, the parentheses are moving. And then we also have, we just reviewed distributive property. The trick with distributive is you start with parentheses, so like in our last example, and when you distribute, you're left without parentheses. Okay, and then we also have some others, like our identity. Our identity properties tell us, for example, if I start with 7 and I add 0 to it, I'm left with 7. If I multiply 8 by 1, I'm left with 8. So the idea of an identity property is you start with 7, perform an operation, you get 7 out. Start with 8, get 8 out. Okay, so let's just look at these really quick. This actually is a Regents question from a few years ago that tripped up a lot of people. A lot of people thought this might be distributive or associative, but if you compare the left side to the right side, the only thing that's changed between these is the M and the 6 changed order. So if you remember that trick, this is going to be commutative property of addition because it moved near addition, even though the multiplication is there. And then the last one here, if we notice, we have parentheses around X and Y. Those have changed to Y, or I'm sorry, 7 and X. So anytime we move parentheses, it's going to be the associative property. And you don't see it, but what operation is really in between all these variables and numbers? Multiplication. Okay, we hope you guys have a great day and keep up the awesome work. We're super proud of you. Take care. Bye.